Morning, neighbors. Something a little bit different, not much though. The Havana Syndrome. You've heard of this, it's worth a Google. My Google first came up with the Wikipedia definition. Havana Syndrome is a wide range of only partly overlapping, unspecific medical symptoms with unknown causes experienced mostly abroad by U.S. government officials. The tags underneath are directed energy weapon, Moscow signal, sonic weapon, yellow rain, radio frequency, microwave auditory effect, and microwave. So this Havana Syndrome is something we've talked about for a long time. Havana wasn't where it originated from. This has been mentioned elsewhere in other articles. But Havana was communist country, blah, 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 good place to blame it on. And apparently it appears to happen more there. I would suggest it might be because the employees going there were informed that this mysterious thing could happen to them. So Havana Syndrome, you can look it up. Most have heard of it. It's older than the relationship to Cuba story is. This is about something affecting people. The reason I bring this up is I've seen some scientists, some people with doctorates talking to the Havana Syndrome, and they suggest 3 causes that could do these effects. And I didn't even listen to the 3 causes. I'm listening to a scientist who doesn't have an answer, not posing how to try and answer the questions. So, why, who, what's going on here? Second part of this is metrology. Now, the Google, simple word, metrology, metrology. It's now an archaic word within America. The conversations to it have kind of been lost because it has become a very specialized field in very specific areas, which we'll talk to in a moment. But this metrology, simply put, it is the scientific study of measurement. Measurement itself, how humans try to measure the real world around us, and the tools that they use to do this. The simplest of them is the measuring stick. Whatever that unit of length is that people agree on at the time. So everyone's familiar with the ruler, unless it's in a different, what's it called? It's a metric system. The ruler is incremented in centimeters and millimeters, whereas the ruler next to it is graduated in inches. So, if you don't have the two to compare to each other, if you're not even aware of the other measurement system and how it works, it's going to cause some confusion. Yet they are 2 measuring sticks. Yes, you might understand one, you might not understand the other. So metrology is how we measure things scientifically, repeatable, reliable measurements of something. And this all started with a ruler. It all started with cash and the exchange, not cash, the exchange of goods and services. It might have been shekels, it might have been gold coins, it might have been seashells. How many seashells do you have to trade for a copper axe, a copper ornament, a copper something to garnish your ear, to go along with the shells you have? So measurements. This measurement idea has carried with us forever. Do we have enough food to survive the season? Was the harvest good for the tribe, for the community? Was it enough for the tribe or the community? Or should we send some people away to go hunt? And if they don't return, the community has enough food, and if they do return, they'll probably bring food with them. Eh? Good old days, those good old days. So metrology, where would one learn this? You would learn it specifically getting into master's and doctorate level research on the human genome. How do we measure a gene? How do we size up a gene? Those little titration strips that give you hints if you're going in the right direction, or test things and change color because of specific chemical reactions within them. Those are defined measuring tools, reasonably precise, and you can go find out that. So metrology is the study of measurements themselves, not the interpretations of the measurements necessarily. Somebody else might do that. This is the instrument measuring what the user thinks it's measuring. Is it accurate? If the user has to certify its accuracy, do they know how to do it? This is metrology. This is tedious bench time and bench work. It might take days to settle something out. You might turn a piece of equipment on for a stability test and set it aside for a week or a month, or you might put it in an oven and warm it up, or a freezer, or a super freezer, and chill it and see what happens. These are some of the tests in metrology, in the sciences of measurements themselves. I have associates, peers in this business and industry that spent their life working on oscilloscope probes and the electronics required for the proper impedance matching, if you can understand what that means in electronics terms, so that the probe is seeing what you need it to see. The probe is able to see a phase discretion between current and voltage. Very sophisticated, detailed instruments. So where would you get this degree in metrology? Europe has some recognized sources for this type of training. The U.S. seems to have fragmented, siloed it, isolated into its own means. And what does this have to do with Havana Syndrome? In order to assess a situation, you have to be able to take measurements. Those measurements have to have some relationship to the real world around you. So what is normal and what is abnormal? What would you use to sense and detect this? So these scientists, these philosophers going off on the Havana Syndrome, fail to mention how you would go after measuring what could be doing this. The physics involved in proving if there are potentially dangerous levels of radiation, of biological hazards, of radiological hazards in the environment. These are sciences we have been doing for a long time. So Havana Syndrome, what is it? Check out definitions. You'll find various, check out videos. You'll find various speculation. There are tools specifically meant. You could lay out a set of them that will fit in a briefcase now to do measurements that answer these questions, that lead to the answers to these questions, that stop the speculation about what's going on. Very precise measurement instruments. Discussing those instruments, their use, would lead you to understand that radio frequency waves can be harmful. The evidence, the proof of this is the microwave on your counter or a neighbor's counter. I have one. It's sitting behind me. I've had one all my life, since before it was cool. My parents had one of the first, not commercial ones existed. The first consumer versions of a microwave oven. Now, I saw that as a child, and then went on to have military training in radar systems and microwaves and high frequency radio waves. In order to get to radar sets, you have to go through radio. You have to understand signal discrimination, signal identification, identification friend or foe, signal to noise ratio, signal directions, how you would find a direction, precisely or less granular. That's metrology, applied measurement sciences. I speak to analyzers in the Hanford region, measuring specific elements and isotopes, but that class of analyzers has the ability to see more. What is it seeing? Can you speak to those classes of analyzers, understand a conversation back from those classes of analyzers? Atomic absorption. In other words, I haven't practiced saying in a long time, but will come back to me if necessary. Because before Google the question comes your questions and putting it in a reasonable format. And understanding Google is not God. It's not an answer. You have to build the answers from complex systems and thinking. Oh my gosh. So where were we? We talked about metrology and the Havana Syndrome. My simple thought is maybe half a dozen antennas and some spectrum analyzers. Briefcase. So all of this would fit in a briefcase. And you go measure these things and you talk about it honestly, because high energy radiation is a risk. To say it's not is a lie to your face. To try to explain it starts conversations of all sorts. All sorts. It can lead to frequencies and crystals and ignorant drivers of the universe and Captain America. So metrology. I was gifted. The reason I got the entrance, passed the entrance exam to a set of classes offered by the Air Force, sponsored by the Department of Defense, that used materials from every large military contractor you can think of, that developed lessons for how to calibrate pressure gauges. Pressure gauges meant to go to the bottom of the ocean and up in satellites. Instruments capable of going to those ranges, working in absolute temperatures. Yes, there's absolute temperature scales. And there's relative temperature scales, and those have two very specific meanings outside philosophical content and babbles. It's like binary choices. You don't understand logic if you think true and false is a good answer, is the answer. So, metrology, precise measurement of things. I was blessed to have the prerequisites to be able to get into a set of classes as a Marine that few others got. I had an MOS specifically to this name, metrology. Its coursework and classes transfer to college level credits. The radar systems course transferred to college level credits. Yet professionals accepted me without the degree through a range of industries. So, metrology, the precise measurement of things. I do not see these geniuses talking to these problems with ways to find an answer. It's interesting. We have ways of finding the answers. It takes people able to use information, analytic tools, desktop-based, and spend a few hours defining something. We had this as a world-class medical system for the state of Oregon. Inputs and outputs. millions a day from doctors' offices and banks and providers across the country, along with inputs from other federal systems that provided us information. For the Department of Human Services, for the state of Oregon to meet commitments in its constitution. These are measurement sciences applied. This is data. This is the largest industry in the world. Understanding that we measure, and that someone can understand and make heads or tails of those measurements is huge. I walked into one of the state university's labs with a sample I did not know how to properly prepare. And the professional I was working with didn't have good advice on how to do that. Yet the instrument sitting in front of him was one of the most capable isotopic identification tools on the planet. A pair of them sitting by side in a state university lab that is actually a private corporation supporting and putting the people in that lab. The lab is specifically set up, and if I had asked about wafer information and how to test my silicone wafer for many things, lots of questions you can ask at that level. You're beyond the microscope. You're looking at the actual atoms, the parts per trillion of doped chemicals on a surface layer. We are amazing, no doubt about it. And it's 16 minutes now, and I haven't made a whole lot of progress. Key word here, metrology, the science and art of measurement. I did go looking for a college or university with that degree title. You want to know how to use a ruler. We would refer back to a global standards organization. You can walk 12 inches all the way back to a lab in America, and that lab in America would point you to a lab in France that maintains international measurement standards. These standards apply bottom of the ocean, they apply on Mars, and we learn more about how to measure every day. It's amazing. It's amazing. And we're worried about second guessing our medical profession that defines human health care in collaboration with universities and educated people across the globe in specific domains of. And then we have, I'm going to loosely call them Republicans. That's not fair. That's not fair. Too long a video. Peace is out. Enjoy the world. Figure it out. Yeah.